speed and precision are the keys to survival. First, there was ShellSweep, a humble tool in the fight against web shells. Then came ShellSweepPlus, faster and more agile. But now, the ultimate predator emerges, ShellSweepX. Like a cheetah streaking across the plains, it strikes with unmatched speed and accuracy, leaving no shell behind. Join us this Friday as we release this formidable tool into the wild, with Michaud and Michael Haag leading the charge. ShellSweepX. The final evolution has arrived. In the wilds of...
Howdy.
What's up? I know I read the text version of that, and just hearing it just so good.
Yes. I think we had another version of it too, but I thought there was another one. I was supposed to make a longer version, but
no.
Yeah, forgot. Howdy, thank you all for coming back. I know it's been a hot minute since we've been live, but
summer's
I think
over.
we're back.
Back to school.
I know. Yes. Get those kids out there.
That's right.
Get back to bringing people on. Actually, speaking of future shows, I think we'll throw it out there now since everyone's jumping on. We have August 30th. We have Casey Smith joining us to talk about reverse proxies. And then the following week, I think that's September 6th. Yep. We have Spencer, Tech Spence, Red Teamer joining us. And then we'll probably take another week off. And then we'll figure out someone else to show up after that.
Yeah, I think we got 2 more in the works. So exciting for that.
Yes.
It'll be good. A lot of fun. Actually, I think we have 3 potentially in the works. But
oh yeah, that's right. We have I need to ping that person. We talked about it. And then I think we have one other one. So yeah.
We have 4 coming up. I feel like we might have 4.
Yeah. We have a busy season.
I don't know how to count. Yeah.
It's busy. But yeah, bringing all kinds of cool content, new folks. So get some fresh blood, talk about some cool things.
Tool drops, everybody's favorite. The final shell.
Yep. Yeah. So yeah, we're kicking it off, right, with ShellSweepX. We've been hyping this for like ever, or at least I have. I've been hyping it forever. Yeah, we're gonna dive in. Mostly it's just a bunch of graphics, just a bunch of pics.
That's all it is.
That's the whole project. It's just dolly generated images. And we went with like this horror theme kind of thing. I had a really cool Jaws one, but it was weird because it was like a shell with like these weird teeth. Like, I mean, it was weird. I didn't show that one.
I should have kept it in. Just because.
I like these ones. This one's cool.
It's pretty slick.
That one too.
I really like the first intro one.
This one?
Yeah, because that's fitting. Whereas like a conch shell just floating in the middle of the woods doesn't really make sense. But it works.
Yeah. There was another one.
But also, can we really call this the final shell?
Oh, yeah. Man, so this is the thing, is a lot of this project I developed last year, and I'm like, how many times can I solve web shells? And so I'm like, this is it. I can't keep chasing web shells.
Do you ever really solve anything in security?
Right.
Is there ever really a solution?
We'll just keep building on top and call it the next gen X.
Yeah, well, we got to keep pace with whatever Gartner and Forrester ship out for new acronyms and whatnot. So we can basically just do like a yearly update and just slap some new name on it.
That's right.
It'll be fun.
Follow the quadrant, right? Like just
follow the quadrant. the only one in the top right corner, ShellSweep.
Yes. Yeah, exactly.
It's a leader and a visionary. It's also niche. Niche.
It's also the only one. Nobody competes. Oh, that's funny.
Can you be even in a quadrant when you're the only competition? Is yourself and previous versions of your product?
It's because I am the quadrant.
I am the quadrant.
You're welcome, Gartner.
We might get sued for this. No, you can't be the quadrant. We're the quadrant.
Yeah.
The lawsuits are coming.
Yes. Oh, that's good. All right. So I kind of wanted to just like share the beginnings, the origin story of this. I don't know if I even have like our timeline slide in here. Nope, I don't. So basically, this all started with Move It. You remember Move It last year? And it was just like, we have this file transfer utility chilling on the edge, happens to house like all this tax docs and organizations, you know, personal docs, and people share stuff this way. And well, it was getting popped, right? Sitting on the edge, web shells are dropping, and it was running on Windows. And I was like, just like anybody else, you know, I wrote security content looking for Move It, W3WP, or whatever it is, dropping an ASPX file. And I was like, there's got to be more. Like, there's just got to be more that a defender can do instead of just looking for ASPX files being written by their web server, web app, whatever it is. And so I started thinking, and so with Splunk, you can execute PowerShell scripts or script through a scripted input inside of the universal forwarder. And I was like, well, if you already have the universal forwarder deployed, why don't you just run the script that like sweeps the endpoint for you? And that was kind of like the first thing. I was like, well, let me share my screen. That was kind of like the first iteration of just like, let's do something different that like is just not out there. And so today, the original tool is ShellSweep. It's also written in Lua, and it's also written in Python. ShellSweepy. Anyway, you can see we had some fun building these. So initially, last year, this was like the concept of just like, you know, take a script that you can just put on a box and run it and find things. You can run it like just on the side as well. You don't have to run it with Splunk or anything like that. Like, just go and run this. Couple of the core concepts at the time when I was developing it was like, you know, I gathered a bunch of web shells off of GitHub, which I think other people do too, for curiosity's sake of just like what's kind of like similarities between all these shells and things like that. And I initially found that using file entropy was like kind of like a really good way to identify web shells. And so entropy is like the randomness and the like, just like it kind of goes through a file. It'll give it like a score in a way, and it tells you like the randomness or the structuredness of that. And it gives you a value, like these values right here. And what I found was that on IIS or with Exchange, I had a 2016 Exchange box at the time. Exchange had a certain range for all the standard files, all the default things in Exchange. And if you change and modify, the range was pretty obvious. So anything outside of that range was a web shell, because that was the only weird thing being dropped on disk. And so I was like, well, entropy is a good like starting point for it. And so ShellSweep initially just started with that. Just do entropy scanning. And I found over time, if you remember with Proxy Shell from Metasploit has a very low entropy. It's a super small script. It's low entropy. And so then I was like, all right, we need to add in the ability to specify different file extensions. So you're probably on Windows. You may not be scanning for PHP. Just rip that out. You might be looking for ASPX, ASP, ASH, things like that, JS maybe. And so you can leave those in there, and then less than and greater than. So now we can capture that really small proxy shell, web shell, and then capture everything outside of, you know, the greater than value as well. So that was like, you know, the very base of it. And then You don't want to scan your whole file system because Windows is extremely messy. And so I added, scan paths. Like, so for this particular case, these are the kind of like, well, the OA auth and the OAB directory here are kind of like the proxy shell paths where shells would drop, and typical paths that drop with Exchange. So just toss those in there. You just restrict it, and you can exclude paths. You can see I told it to exclude this OA auth value path right here. Ignore hashes and all that too. And so, like, my first question was, and I hope someone's asking it, maybe not. Nope. Okay. My first question at the time was, I need to be able to kind of like quickly scan the file system and know what's there. And so that's kind of where these other tools come in. Shell CSV basically scans the file system, gets the entropy values of those directories, and then it outputs, what's out there. So again, tell it where you want to scan, what you want to scan for, things like that. Again, you can use my Exchange stuff as, if you want to scan your Exchange box. You may find there's nothing there in your environment, or if you've been popped, you might find some cool randomly named ASPX files, which is cool too. Maybe not. And then the other one here is Shell Scan. This one basically does the same thing, but actually outputs the full stats for you as far as like min and average and max values of your entropy. And so for me, the idea was, you can see my directory paths right here is all these web shells. And so I scan 2,800 web shells. I get the min max of each file extension. And then I use that to drive those values inside of ShellSweep. So that's kind of like the full circle of how the scripts kind of work together. That was ShellSweep. Here's the Lua version. Well, that's ShellSweepPlus.
But you didn't stop there.
Nope. So ShellSweep went out. We presented it at Black Hat last year, and my coworker Eric, who's been like a really great advisor with the project and has like given me a lot of really cool ideas and crazy thoughts and stuff. And he was like, "Hey, like, what if we add like weights and scores and do some kind of like heuristics and like look for patterns and things like that?" And so right after Black Hat, I got back to it. This is Black Hat last year, 2023. And then I started thinking too, I was like, well, what if we do standard deviation and just like all these different ideas? And so after Black Hat, ShellSweepPlus was basically written and shipped kind of quietly, didn't really share it publicly. But I took all those web shells and I had another script, which is in the repo, called shell extract keywords. And this script will rip through all your web shells that you've collected, and it will output a PowerShell, quick array thing here of all the suspicious keywords. And I'm looking for anything more than 3 times, which it could be low, could be high. It just depends how you want to sweep it. But that ends up filling in this whole ginormous amount of keywords that are in all those web shells that have been seen more than 3 times. And the more you up it, say you want to look for 5 times, the list starts to get kind of reduced at that point. So I felt 3 was good, 2 was too little, 1 obviously would just be chaos. So 3 was kind of like a good, decent middle ground. And then before I even shipped the tool recently, this was in the last 2-3 months, I added this whole like heuristic pattern thing. Just another way to kind of like help with going after anything in web shells. I'm just trying to add as much as I can into the script. So there's all these crazy like patterns, just insane. And again, it uses entropy, so manages that as well. Like I said, it gives you scoring, which the scoring ends out like giving you a decent confidence score. So when this runs, it'll tell you like, yeah, 100, this thing is definitely a web shell based on the amount of heuristics and the amount of entropies and standard deviation and all this stuff, puts it all together and kind of mashes it. It's really crazy. just like the amount that's in here. And again, you can run this with Splunk Universal Forwarder scripted input, or you could run it one-off as well, and it outputs in a really nice JSON format. So you could actually just kind of take it and toss it into something else, or output into something and kind of run with it as well. They're all meant to output really clean, so you're not like going to get like left in the woods of just like what the hell just happened, because it's a lot of data. But yeah, this one's really cool too. Which last year, when I was really digging into ShellSweep and all this stuff, we started thinking of, Eric and I kind of like brain melded ourselves to think about like, that's cool. Like you can run one-off scripts, but if you're a large org, you have an amount of web servers. You don't have all day. IR doesn't have all day to go box by box, running a random script, finding all this data, and then like, or updating entropy values, or like figuring these things out, right? It takes time, you know? So last year we started like digging with the idea of like, how can we scale ShellSweep? Like, how can we make it to where, you know, it could be something central where you can upload files to it somehow, and then like kick off the engine, kick off the scanning, and have the scanning and everything central, because all of these are running on the box and they can consume memory, and it takes time if you're like YOLOing the whole C drive or something, or the whole Exchange directory, or all your web server web apps running on a box that you have multiple on one or something. Like it could really like burn it out. So we started dealing with that, or looking into that. Centralization. And the other thing too was like, is there something better beyond entropy? Is there a way to like really dig deep into a web shell and do it without heuristics or any kind of pattern matching and stuff like that? And so that's when we got into machine learning. And so let me switch back to the slides actually. Oh yeah, I talked about shell scan, shell CSV, those feed into ShellSweep. I guess I did have the graphic there. Oh yeah, we talked about this too. Like I mentioned, the low high entropies are things that are out of the normal bounds of your expected entropy when you scan. So that's kind of where they all kind of come together. So anything in that blue expected entropy values there, we basically found that Exchange rarely deviates out of those ranges. And that's because their code is just structured kind of like more formal, and it's more obvious. So the entropy is pretty standard. But anything outside of those ends up being a shell. Yeah, I talked about that. Okay. So initially, this was ShellSweep ML. It was a Streamlit app. And luckily today, I actually have it running. Let me share that somehow. Here. Oh yeah, look at that. So it was basically, you know, just copy some files up, tell me if it's a web shell or not. You could search, choose the amount of pages, things like that. Enhanced it with all kinds of crazy crap. So like you can go to virus total, you could view it. You could view the file contents. So all web shells are stored in the database and run SQLite on the back end. You could view them and, you know, confirm yourself. You could download it, because sometimes you may just like realize like, hey, I actually need that file. I want to look at it again, or run it, or do something. If you want to get like another triage of it, you could use GPT. At the time we were using GPT just to kind of like give us like analysis of a file if it was like benign. You can see entropy, standard deviation, things like that's all still here. What else? You could ship it to VT if you wanted to do that too. And then the nice thing about this is we had built out a whole stats page in here, just to kind of like show the amount of data we were throwing in here. So at the time it was like 2,700, tons of web shells detected, 10% were considered benign. You could download things, you know, your hashes and stuff. And then just like some stats, like if you needed to throw these in a report or whatnot, or you wanted to show like how much stuff you're scanning, file extensions. I thought this one was cool because it kind of gives you like that entropy distribution of like where all my shells kind of sit at. And you can see kind of like a little bit over almost everything over 5 is a little suspect. But you can see the ranges. There's like this value between like a 1.5, let's say, up to like almost 3. It's kind of like a dead zone for web shells. And then, yeah, you can see some get pretty wild out to the far. And then we did at the time kind of built in this very basic feedback loop where we got this feedback actually from one of the data scientists, and they were like, oh, you should, have some kind of feedback in here where like an analyst can confirm or deny. And then it should go back and like feed into whether the model retrains itself. I don't know. So there's a little bit of like thoughts on the whole like feedback loop retraining and making things better that I have on that, but I don't know yet. Not so sure. So anyway, this was shelved. We never shipped this, and it's kind of neat though. Like just a random like Streamlit app doing all these crazy things. I'll share that that link here to VirusTotal. Forgot, but that VT link leads you to the giant collection of web shells that I've collected, and I just basically tagged them on VT and put them in a collection so that you can play with them and click things and download things if you're bored.
Or
so yeah, a lot of words. Yeah, I guess I could ship over to my box and we could just run some of these scripts and see what they look like.
Yeah, let's take a look.
Let's go live.
Absolutely.
Stop that screen. Share another screen. Windows, this guy.
It's too many windows.
All right. You should see my VM, bunch of small text. Yeah, so just figured while we're here, I more or less just modified the scripts to just scan a small directory. It's ctemp small. And then I left everything else default, haven't changed anything. So I'll just run
how small?
122 files. So you're just going to see a bunch of things go scrolling across the screen. And some red text. And so it just hits the directory. This is the base output of like entropy, the path, and the hash, last modified date and stuff like that. So this is like OG ShellSweep finding web shells on disk, more or less. This is just how it worked back then. And this output is in a particular format, the JSON format to ship to oops. And then let's do shell scan. Shell scan will go and again do the same thing, but this time it's going to give you all the stats of everything in those directories. And so you'll see here, it even tagged like cert files, rar, ASPX. So these are the values that you would take to drive. The idea would be you scan your web server, your Exchange box, whatever. And based on these ASPX values, this is what you would put into ShellSweep to drive that. So then you don't have to guess and things like that. So you see JPEGs and things like, yeah. So this is where it gets kind of interesting with entropy is you start to see like how JPEGs fit, how PNGs, what their entropy values are. I do have a larger directory. Let's go back. I think it's under temp. Web shell master here.
The shell scan is probably good for post update or post install before deployment, just to kind of baseline what those directories potentially would look like before things start hitting it.
Baseline, exactly. Yep. That's its whole kind of concept of giving you these values so that you can understand what's there and drive what you want to put into ShellSweep. So this one's going to be a little bit crazier. We'll see how long it takes.
How many files in this one?
A lot.
Define the word a lot.
There's going to be
3,000 files. Is that the big shell directory?
No, maybe 600 or so. it's a little bit of everything too with all the different types of web shells. But yeah, Perl, there it is right here. So that wasn't too bad. But now you could drive, what's that? Oh,
So that was like 5 seconds. I thought we were gonna be here for like minutes. Like we have to fill it with something.
It's not that bad.
I know.
So yeah, now you could drive your PHP, ASPX. You get a lot different values now, but you'll still see like your median is still like a 5.3. Even the smaller one was around that range as well. But all the other kind of web shell types, ASHX, things like that, even Perl up here, where'd that go right here? You can kind of see their values and drive however you want to kind of manage it within your shell sweeps, things like that. Yeah, it's pretty cool. And again, that's really, like you said, meant to drive like a baseline of what you're going to put into your entropy. Yeah. And then, so let's go ahead, let me swip over to show SSP. Go there. There. And so its output is going to look a little bit different than ShellSweep looked, because now you're also getting your detection method. So in this case, entropy based, a confidence score, 100. This is definitely evil, your entropy. And then it also gives you all those suspicious keywords that it keyed on. So if you were like splunking it or putting it into a log or into a sim or whatnot, you can see all the matches and whatever it's like tipping off on, which is really cool. And it just kind of keeps going. I thought I just saw heuristics right here. Yeah, so here's some of the match heuristics. So again, it's looking for those different pieces that we had added to the script itself. And you can kind of see it's kind of lagging a little bit. This one's a little bit heavier on a machine because it's analyzing a lot more stuff within these files. But yeah, pretty cool. The heuristics partially came from like just going through different Yara rules and just like pinging and digging through, you know, the commonalities of web shells. So that's where the heuristics kind of drive and where they kind of piece out to, like just different functions that are within these things, within shells. So, but yeah, really powerful, a lot more verbose, which I love, because if you're an analyst and say you are like actually sweeping your servers and you're dumping this into your SIM or whatnot, your analyst can tee off of like, oh yeah, like we know that this copy function or PHP info or exec is like definitely high fidelity. We want to make sure we're like teeing off and firing on that all the time. You can create alerts based on scores and whatever. Yeah, it's just really cool. And this one keeps running. I know there's a lot of shells. Yeah, so I do inside, there's a good question in there. Shipping it with the Windows Splunk TA. We don't, but we do have the scripted inputs on the blog. So the ShellSweep blog and the ShellSweepPlus blog both have the scripted inputs. So you could just like copy paste it, drop it into a new inputs conf, and just run it, and then you're kind of good to go. But yeah, leave it up to the user because I don't want to be the one causing that performance damage. So yeah, that's going to go. We did the small directory, which is 122 files, and that's going to do its thing. And it's lags here on one of them. But yeah. Probably should have picked a smaller directory. Yeah, what else? So that's kind of all that. What else? I have another tab. So back to the machine learning piece. I think that's important to talk about because we did have a lot of questions on it initially when we presented a little bit of it to the machine learning team last year and what we were using. And I think when I even tweeted it last year about ML, and yeah, yes, the kind of like response we got was like, why would you use term frequency, IDF, and all this stuff? And it was just like, well, I don't know, like it just worked. And like when you're just learning machine learning, kind of pick the most basic thing. Like you Google, like, what's the easiest way to detect terms and whatnot. So like term frequency, IDF kind of was like the jam. And you're like, well, what the hell's Mike talking about here? Let me pull up this piece of what kind of like this means. So term frequency, inverse document frequency is the vectorization, and then we use logistic regression classifier model. So there's like two pieces. And actually, let me go back. Yeah, there's a link right here. So the wiki's up to date. I updated this on the ShellSweep repo, which I guess we could put into the chat. I don't know where the window went. There you are. Okay, so there's that. We give you the script to train it yourself. So it's called like train something pi, train model pi. And so it basically uses TF, term frequency. If you open up the database, it's almost readable, or the model, yeah, the vectorization like database itself. It just like all the terms that it's identified in these web shells. We took all the evil web shells, 2,800 of them, and then we took a mass amount of like 6,000 benign files. And then we said, here's good, here's bad, do your job. And so that's how it was trained. It ended up like popping out the other end, like a super solid machine learning model, just with term frequency. And I don't know why we chose it. It was actually easier than trying to like go down that road. I can't remember what, there's like a really advanced one. Is it like BERT model? I don't know. There's like some crazy ML things out there, but this was like really easy to do and it's not hard. And so that's why we chose it. There is this thing in here when you do train it called features, and you can customize it as much as you want. We tested it at like 1,000 features, and then we tested it at 10,000 features. It just gets bigger. And so 5,000 ended up being a really good middle ground of benign and malicious. So with all of that kind of slapped together, 5,000 was a really good middle ground. So we give you the training script. So like if you, for some reason, have 10,000 mass amount of web shells that you want to train it against, and even more amount of benign files, you can change your feature set to 10,000 or whatever, maybe keep it 5, whatever. But you might end up finding that, you know, there's going to be a middle ground somewhere in there. So it works out really well. But for the amount we had, 5,000 was great. And again, this is under the train model pi, and that is under the ShellSweepX directory. And it's just right here. You just specify your paths. Benign, where's it at? Where's the malicious? Right here. And then there are ways to exclude words, which is the common top words. It's very minimal. I didn't exclude a lot. And then you could change your feature set right here. So if you have a much larger set than we did, then this would be kind of the way to go. But it works. And when we initially played with this last year, the model is just insanely accurate. And so that's kind of like, we ran it, and then we uploaded all the web shells to it, and it pretty much captured all of them. And then we put all the benign files into it, and it was just like, whoa, like this is insane. And then like if you deploy like a random like WordPress site and you upload the files from that, like it just all, if there's nothing malicious, most everything will be benign. So it's really powerful. The other comment we got last year was when ShellSweep dropped was, why don't you just do Yara? Just run Yara on your web servers. And I was like, okay, I guess you could, right? Like deploy Yara, you know, on an Exchange server and find out what happens. So I wouldn't. So that's where ShellSweepX kind of takes all this to the next level. I rebranded ShellSweep ML. We got away from the Streamlit because I do too much in Streamlit. And so like, let's learn something new. Another initial concept of ShellSweep ML was actually compiling using PyInstaller and just like compiling it into an executable and just running a binary on the endpoint. So I had the model and everything built into a bin, and you would just run that and it would tell you what's good or bad. It was crazy. It worked, but it's like a 90 meg bin, and it would consume a ton of system resources to run a whole machine learning thing on there. It wasn't, what's the word? Remember Cylance? It wasn't that. This was a lot bigger. And then, yeah, so initially also I wrote it with Flask on the back end. ShellSweepX, part of the rebrand, was using Fast API. Fast API is pretty similar to Flask. Maybe it's faster. I don't know. It seems similar to me, but all the endpoints and stuff is really clean, and I dig it. Something new to learn too. And yeah, we also moved to an agent way to run these things by agents. Runs Yara, runs that machine learning model, does all that stuff. And there's some really cool things about the agent stuff and the way Fast API works. So like one thing I really wanted was like, I didn't want folks to like just be stuck in with like an agent binary or whatnot. So, and I didn't want to give someone a binary and say like, just run this unsigned binary, good luck, YOLO. I really wanted it just like, what's native? Like make this native and like have you run that. So everything's written in PowerShell and Python, Windows and Linux. And so you can click through these here for the agents. And there's a whole diagram on how this actually all operates and flows, like what it does, how the agent operates. There's 2 scripts for each Linux and Windows. One's the actual agent. This is the one you would set up with like a scheduled task. And then there's the other one. I'll give you the scheduled task here too. And then the other one's like an actual scan script, like just scan this directory and send it to my server. Like, and maybe if I want, I'll tell you a directory to scan and I'll tell you extensions to scan for. So you don't just flood your server with like a crap ton of like benign files all day. Same with Linux, does the same deal. Shell scan, or yeah, it'll do the sweep, the full scan, or agent based, whichever you prefer. It'll do a cron as well if you want to do cron. I think it has it in here. Yep, right here. So you can do all that. And then the other thing I wanted to get away from was here. Let's just switch over to ShellSweepX. We're talking about all the cool features without even showing the tool here. So this is it. I uploaded a bunch of files, basic little dashboard here. You know, when your agents are checking in within 24 hours, shells detected, how many scans or how many files were scanned there. I'm going to switch back over to that agent piece because I think that's where I was headed there. So you could download your agents right here in the UI. And then no longer do you have to configure all those entropy values inside the script. Everything's managed on the server now. You can go in here, change all of this, add different conditions. I want to do less than, remove, you know, however you want to handle it. It's all up to you now. You can now just remove these. Like I don't have PHP, like we don't even run anything Linux here. Like everything's Windows. Like just keep adding all these like native Windows ones. Directories
What
to
about
scan.
what about my PHP on Windows?
You could add it back.
Okay, good. Especially
yes.
with those special language packs.
Yes. Yeah, you never know, man. Right? You might be running Nginx on Windows. LAMP.
You could have a non-standard language pack of PHP running on your Windows server that you didn't know.
It's true. You might want to just scan for it all. You know where it's at. All right. All your directory exclusions, everything's here now. It's just hosted on a YAML file, kind of on the server side. And if you dig through the way the agent config works in the wiki, it basically, agent will check in. You tell it where to check into. It grabs the config. The config tells it all this information, and then it just scans. There are some cool things about it, and it's all in here under the agent stuff. Part of it is, that's the agent config. Part of it was like, I don't want to keep rescanning over and over the same thing. So it does keep like a little epoch time or a little timestamp of the last time it's scanned. And it does that based on the file stamp of the files too. So like when it scans, it says like, oh, you're not new. Because you think about it, your initial scan is going to find potential web shells there already. If there's none there, awesome. And then moving forward, if a web shell drops, it'll be dropped today, today's date, and that's when it's going to get scanned and get picked up. So it kind of helps with like that performance, doesn't have to keep rescanning the whole file system all the time or all those directories all the time. It's really cool. And yeah, it works really good. So yeah, agent config's wild now. Really happy with it. And then, yeah, back to your dashboard, back to analysis. Now, I mentioned the Yara integration, the machine learning model, kind of like those two things combined. It's really powerful in detecting a lot of web shells. I have found that there are some shells that the model itself does not do well with, and it's typically web shells that are heavily obfuscated, which is again why like the Yara piece is very important to kind of have just for that combination. I don't know why this one was missed, but it was. And then this one, either too short, too small, I don't know. Sometimes it just misses different shells. There was one that was really good. Yeah, this one's all like sketchy looking. You can see, but even just like the one kind of generic Yara match, which is great. The one thing that I wanted in here, which was I mentioned with having like the GPT integration on the original ShellSweep ML. I don't know where I did it. Where'd it go? I ran it earlier. I don't know where it's at now. But there it is. So this web shell, you know, you got your 2 hits here from Yara, but benign on the model. The content, it kind of looks generic. Like I was surprised. And then when you have Claude, I'm using Claude. So it does integrate with Claude or GPT. Pop in your key and then kind of let it go. And you'll see that Claude was like, yeah, this is definitely a shell. And then he breaks it down kind of piece by piece for you, which I think is really powerful. And you can see, you know, what he's teeing off on, just the different parts of this shell, which I thought was cool too. It's kind of neat. There are instances where if you try to send a really large shell that has like shellcode in it or something, it's going to take a while and you probably won't get a response back.
So the Yara scanning, where are those Yara rules being pulled from, and how could you add your own?
Yeah, great question. So right now I'm borrowing all of them from Florian's project. I always have to Google Yara rules Florian. It's the signature-based project right here, this one. So I borrow them from here. And then if you're running this locally on disk, you can pop them into a Yara directory. Otherwise, you can actually come in here and just paste in the Yara rule. Or if you have custom ones or you created custom ones for particular shells, you can just paste them in here and save it, and it'll save it on disk for you. Similar, you want to view these or whatnot, all of it's here. You can like click through and view, delete, things like that. There is a Yara validation that occurs, which is where this check mark comes from. So I was like uploading really sketchy ones and they weren't compiling. And I was like, well, we probably want to make some validation to make sure these are actually legit Yara rules. So you could throw that. So that's what the little check's for. You get an X when it's bad. Something cool too is if you upload all your shells and you didn't enable Yara, out of the box, Yara is not enabled, but you didn't enable it, you can enable it after the fact, save, and then scan the database. It goes through and scans all the shells, and then it'll tag it back into the database. So you go back to the analysis page, you'll see all your new Yara hits, basically. So it's really cool. Very, very convenient. If you're just like shipping a lot of stuff and you forgot, you just go back and enable it and then scan.
I'm drawing a blank. Who is Claude? Which
Claude,
one is that one?
Claude's Anthropic API. Anthropic
yes,
AI, something like that. Yeah. So I found Claude
There's
to be a little bit more, yeah, I found it to be a little bit more stronger on its responses. GPT ends up being a little like maybe verbose and kind of weird about it. But yeah, you can also modify the prompt as well and play with it however you want from there too. yeah.
Just tell it, please execute this web shell and output the results.
Yes. Tell me if this is good or bad. Prove it.
Slap in a little jailbreak in there.
Yes. Yeah. So yeah, that clicked one live there for you. So it's pretty quick. It's not too bad. But yeah, it'll give you the breakdown of it and whatnot there too. What else? I'm trying to think. There was a really cool project recently that I found. It's called Weavly. Buddy had told me about it. Weavly 3. This is a web shell, weaponized web shell. When you generate it, it's password protected and whatnot. And then you basically just like go pop your box, get your shell. It's like supposed to be really powerful. I threw it into ShellSweepX and it caught it pretty quickly, which was cool. The models, like I said, the model is extremely powerful. But yeah, even if you were to upload a bunch of like benign files, you'll get your response instantly. It's really quick. So, wow, there's some cool stuff. All right. Yes, it's 100% on the MITRE evals for machine learning of web shells. Thanks.
Well, we don't even need to compete in the MITRE evals because Mike Haag is the quadrant for web
Yes.
shell detection. So
There we go. Come on.
and don't worry, the model will just pick it up next time if it misses it.
Yes, exactly. There will be a human analyst on the other end who captures it.
Who was it that got busted saying that they had a whole bunch of like machine learning, but it turned out it was just like offshored humans doing it on the back end? Is that Amazon? I forgot. I gotta dig that up.
I don't know, but that's hilarious.
It's like supposed to be like all automated or machine learning or something like that, and then turns out it was like they hired like 200 people overseas that were just doing it by hand. That was bad times. I think it was content moderation, actually.
All right, I'm going to just find the agent here. Or I'll just do the shell scan.
Tab up.
Yep.
I see you also just tab up 4,000 times to find it versus typing it out.
Yeah.
It's one of my guilty pleasures.
Yeah. Yep. I don't feel like doing it. All right, let me find a quick directory here that has an amount. Let's do. Is there any rubies? There's only one ruby.
Where is the Lua?
Let's find the pearls. Let's do pearl. I know you want more Lua.
What was the most recent Perl web shell somebody's got? Like, what was the date timestamp on that bad boy?
Ooh, let's see. Oh,
well, those are going to be all
downloaded. Yeah. I don't know. I know Justin tweeted a Perl web shell the other day. Yeah.
Justin, where's the shell? We need to test the model.
So yeah, this is the scan script. So ShellSweep scan verbosely 25 files of pearls, and it basically just went through and sent all of them to the server side. So if I just switch back here, sorry, I'm gonna keep switching. Whee. So if you go back to ShellSweepX and refresh, you'll see all the Perl files here. And tell you which agent's sending it, which I think is so handy. And these are all web shells, so they're all been tagged appropriately. If you're noticing it, there is no Yara matches. There's not a Yara rule for everything. So that's kind of where having both of these is very powerful, kind of combined. And then obviously entropy and things like that too, so you can kind of see all of that. Let's see. Let's go back.
What a deviation number on that one.
Yeah, I think there might be a standard deviation issue that I have failed to go and finish.
That's fine. Nobody's using standard deviations.
No. Yeah, nobody. All right. So here's the agent. I'm just going to kick it off as verbose because that's kind of an important piece. You can kind of see the whole agent process of it. So again, it checks in, grabs the config file. It does use GUIDs for agent IDs so that it's not like the same machine checks in and it has like 5,000 check-ins, 5,000. Yeah, I ran into that. That was hilarious. Checks in, blah, blah, blah. It receives what it's supposed to do. And in this case, it already had scanned the directories. I'm going to go and do some quick deletion here. All the files are saved to disk, and this is on the wiki as well. So here's the agent ID, here's the config. So if you wanted to open this, this is what it's been told to do. And kill that, go back. And then I'm actually going to delete that last scan time. And then we'll kick it off again, verbose. And you'll see it go crazy here. And so you can see it starts posting it out to the server. And then after this, I'm going to talk about the API, which again, kind of like Flask, fast API. The cool part is if you are dealing with edge devices, which happens to be where a lot of Lua web shells happen to live. The nice thing about this project, being it's central, you deploy it as a central server. The nice thing about it here is that you can now just like ship this data in however you need to. It doesn't have to be through these scripts. It doesn't have to be handled through a PowerShell script. You can curl it in. So you're working on your Cisco or Juniper or whatever appliance on the edge with your Lua web shell on disk. I gave all these in here. Everything's here for you. You can do pretty much everything through a curl command as you could through PowerShell or Python. You want to send files, you want to check in, whatever you want to do, all of that's here. Yeah, so you can ship however you want, connect, ship, send, all the things just through the API. So there's no need to you could write your own code however you want to ship it to. So if you're like, I want to commit a Lua a Lua agent back, you can do that too.
So what you're saying is, I now have edge device detection using ShellSweep.
Exactly. Yep.
Money.
So yeah, you are worried that, or you know that an adversary has been accessing your edge device. Curl is typically always on these devices. So you drop in there, you drop shell, you can start curling a directory, common paths. Maybe you know the common paths, or you guys could Google it around, or you read a report. You can just tell it the path, or just ship it all and find out what happens. Doesn't hurt, but you ship it in. ShellSweepX will do its magic. Yara will do its magic, and then you kind of have it all in one. You get all your visibility into what was on that file system for that edge device now. So it's pretty powerful. I think. Yeah, here's the samples right here. It just posts to this API agent results. You just kind of tell it the path and just kind of goes from there.
Slick. Now,
or a SOAR product. If you have a SOAR product out there, same thing, right? Like web servers admitting weird behavior. I want to kick off a SOAR action workflow thing, playbook. I don't know what it's called in SOAR lingo. You kick it off, goes and grabs those files, or a directory, scan a directory and send it off. Oh, there was another question too about using live response with EDR tools. Yes, you could use the PowerShell script, Python script. Obviously, you can write your own, whatever it is based on the product you're using. Write it however you need to write it, and just ship it off to the API, and it'll just process it for you.
Slick. Now, question on the agent side of it, because you mentioned that each one gets its GUID. Have you run into any issues with potential collision for something like containers, where you have something that potentially gets thrown new things with the same naming convention day after day or every few hours, or something happens and it gets a redeploy?
I haven't. So something else I have in the project, and if you go here to test, I actually have unit test and regression testing. And so the idea for regression is that it basically just hammers the server, testing out all the functions of the API, and it will simulate agent check-ins, but it is a different computer name every time. It should be a unique ID, agent ID for each one. I'd have to play with it more. I don't have a container environment or a large environment or whatnot, but every agent ID should be completely unique.
Right.
I actually,
Because I was thinking, if that container gets the same name, though, you potentially have 10 of them with 10 different agent IDs to then track through as they roll.
yeah, yep. I don't know. I'd have to play with it.
Because could be an interesting thing of how to find some unique way so that if it is in like a containerized instance, you kind of just merge all of those points back together. Sounds like a nice challenge. I have no idea how you do that.
Yeah, I don't know. It's kind of like EDRs with proxies back in the day. Like, I don't know. All right, so in the background, I'm running regression testing right now. So if you go here and click refresh, these are the regression shells coming in now. And so it's going to create agents. Here's the agents. And if you go to agents as well, here they are starting to check in right here. I'm not as well too, Paul. Like, I'm not sure how many folks are truly going to actually use this. So I'm kind of like curious, like getting people in here and to like start playing with it or using it and just seeing like what the feedback and or requests are, because I'm not sure. I'm not sure what requests might come out of this project yet. Really curious.
So a call to arms of go deploy this in prod and tell us what breaks.
Yeah. Yes. Exactly.
The PRs and MRs are open. Feel free to submit them.
Yeah. Yep. Couple things. I don't know if you caught this as it was shipping, but the regression script will do burst. It'll burst up like a random amount of shells at a time. These are very generic shells. There's nothing evil, just kind of very generic, but enough to trigger it. So that's what it's doing. It'll burst them. It'll send up individuals. It'll do individual agent check-ins. It will also test out Claude, making sure your AI stuff works. So here's a Claude response right here, kind of telling you what this is and whatnot. It will attempt to do burst benign files, but for whatever reason, the benign files end up being flagged as a web shell. So whatever. So it just kind of happens. Yep. Everything's evil until proven otherwise.
I mean, facts.
So it's getting hammered. So yeah, here's a test benign. Being flagged, but it just says hello world, but I think hello world is enough to trigger it. Again, the way term frequency works is it looks at terms of the shells or what's in the shells. So it can kind of like get a little mixed up. It might have like hello as a frequency word and whatnot. So, the other caveat for search. And so as we're hitting time, in the wiki, I do have like a feature updates and known issues in here. There are a couple things in here, like searching content of web shells. I had it to where initially this search would search everything in the database, and that's chaos. Because web shells can be extremely long, and you're keying off of like web shells that have freaking shell code inside of them. So, and it's scanning everything. It's like a SQL query, right? SQLite on the back end. I removed it for the time being. I couldn't seem to get it tight enough to where what I wanted was to say content, and then you can type in like whatever, command.exe or something. I wanted that, but I couldn't get it to work properly. So that's been removed for the time. If you want to search inside your shells, maybe we could figure something out. Because I'm still interested in it, but I'm also not. As shipping. This is the final shell. Like this is literally me finishing the ShellSweep.
What I heard was
biome.
this is beta, and next year we release V1.
Yeah. Yes. Yes. Maybe. So
That's not what I heard.
But yeah, man.
Great stuff.
Hopefully everyone found that kind of interesting and wild and weird and just another project.
I don't think other than potentially like your endpoint stuff is doing much with web shells. So this is kind of interesting, especially in the defensive side.
Yeah. I mean, AV struggle
cool.
with web shell every day. You know, web shells just, for as plain text as they look, AV struggles. You know, they don't want to flag an exchange file, all that. So I think this project's really cool. Nish, top right, Magic Quadrant leader. You're welcome. 100% MITRE eval winner. I need to talk to Jamie. I need to get some trophies on my project that say like MITRE 100%, 110.
Just take them from the website.
Yeah, I'll just start pasting. So yeah,
just crop out like the trademark things on there. Be good to go.
Exactly. Yeah. So, but yeah, give it a shot. Let's happy ShellSweepX, and hope everybody found that interesting. We will catch you in 2 weeks, August 30th, and Casey Smith will be here.
Like Ngrok.
Yes, Ngrok.
Can't wait. We've only been trying to get Casey on for what, like 2 years now?
Yeah, pretty much. Casey, you should, if you're not listening, you've been called out.
Oh, he's around.
Yes. Yeah. Thanks, buddy. Hope everybody has a great week. We'll see you on the 30th.
Stay fresh.
Bye.